Hello class, we're about to start the second part of the final exam review. Now, just as a way of having you all remember from the email I sent yesterday and the email I'm going to send today, remember there are 4 reviews that you have to do for the final exam. The first 2 are midterms part 1 and part 2, and then the last 2 is the final exam part 1 and part 2, and that covers everything that you need for the upcoming final exam. Also, as a reminder, on the video for the midterm part 1, I believe that is section 2.7 is at the beginning of that video. So you have to skip ahead a little bit in order to go right to the review, but it is on there. Also, project 4 is due this coming Saturday. Please make sure you turn that in. And then also I sent out the email for the final exam, which will be administered next Tuesday and Wednesday from noon to 1 p.m. Everyone was supposed to notify me by yesterday, I do believe. No, it was actually Tuesday that you were supposed to notify me whether or not you could not take it on that day. And since I received no notifications, I expect everyone to be ready to take the final exam on Tuesday from noon to 1 and Wednesday from noon to 1 of next week. And that will be the 15th and 16th, because it will be a 2-part final. And again, you must sign in the same way you did for the midterm. You are to go to JetNet. As a matter of fact, let me go ahead and show this to you. As far as signing in to the final, let me pull this up here. Okay, so first let's go down here to the final sign in. Now, what you could do is 1 or 2 ways that you could do this. I will send a link for you all to sign in to the final, but then also you could go back here to where the midterm is, and you could do a midterm Zoom meeting. You could click here, and what I'm going to do, I didn't do it yet, but I am going to put this on here under week 8. Well, here it is right here, final exam classroom. All you have to do is click here, and it should take you to Zoom. It'll take you to a Zoom meeting. So this is what you need to do under week 8. You will click on final exam classroom. That'll take you to the Zoom meeting. And then as you all are there, I will give you instructions as far as the passwords to the final exams. Okay, now, as far as I want to talk to you all about the project again, just to make sure you know where to get the project from. You'll go up here. You'll go to projects and click on it, and you will have the new unit for a project. That's where you're supposed to go for the project. And also, and remember, I told you all yesterday to re-download the project because I had changed it. So if you downloaded the project before Wednesday, or before you got my email, you need to go back and make sure that you have the current project for. Now the exam review, same thing, click here in this folder, and it will have all 4 exam reviews as shown here. And we're doing the final exam review part 2 today, but I did send the videos for the midterm review part 1, part 2, and the final exam review part 1. And today I'm going to complete part 2 of the final exam review, and then you will have all 4 videos to look at. Okay, now, if you have any questions about anything, please let me know, because I do believe that your homework is also due this Saturday or Sunday night. We will have to check that. You could check that in Alex. It will let you know. And then come Monday, you should know where you stand at in the class going into the final exam. Now, I do want to go over this final exam review. Now, we know this is part 2 of the review, But just like with part 1 and the midterms, if you go down here to the last 2 pages, you have the answer key with all of the answers for each of these problems. Now we're going to go through each one of these step by step. So let's get started. It says here, write the word or phrase that best completes each sentence or answers the question. Of the next 32 trials on the docket in a county court, 6 are homicides, 11 are drug offenses, 6 are assaults, and 9 are property crimes. If jurors are assigned to trials randomly, what's the probability that a given juror won't get an assault case? Now it says that they will not get an assault case. So we have to look at this. First of all, there are 32 cases, as stated here, 32 trials. Now we're going to look for the assault. Well, we could look at all the cases aside from the assault cases. So we got 6 homicides, 11 drug offenses. So far there's 17. And then 9 property crimes. 17 and 9 is 26. So 26 out of 32, which we could simplify. Now we can do this by hand, or we could put this in a calculator. There's no shame with that. Because remember, this is what the technology is for. And you can hit this key here, and it'll give you the simplified fraction. 13 over 16. So that will be your final answer. Now we move on here to problem 2. It says, if a die is rolled 1 time, find the probability of getting a number greater than 2. Now remember, we have to remember about a die. Remember, a die has 1, 2, 3, 4, 5, and 6 on it. Now they ask us to find the probability of getting a number greater than 2. The numbers greater than 2, there are 4 of them. So this would give us 4 out of 6, and simplified would be 2/3. So your answer here would be 2/3. Okay, now we go here to problem number 3. It says, if you add the probabilities for every outcome in a sample space, the results is always 1. Because remember, 1 represents every possible outcome. So if you add all of them up, it represents 1, or 100%. Okay, number 4. In a classroom, the students are 9 boys and 4 girls. If one student is selected at random, find the probability that the student is a girl. So we have a total of 13 students. And then it tells us that 4 of them are girls. So it's a 4 out of 13 chance that you would pick a girl. Okay, number 5. A box contains 5 blue, 8 green, and 3 yellow marbles. Okay, if we look at that, 5 blue, 8 green, and 3 yellow marbles, that would give us 16. Yeah, that'll give us 16 marbles total. If a marble is selected at random, what is the probability that it is green? So first of all, we know that the denominator, or the total amount of marbles, is 16. Now, it says if a marble is selected at random, what is the probability that it's green? So it'll be 8 out of 16, and we know that equals 1/2 when you simplify it. Okay? So now, we move on down here to problem number 6. It says, construct a stem and leaf plot for the following data using whole numbers as stems and the decimals as leaves. Okay, so they basically solved the problem for us here because they told us how we want to do it. So we know we have one side is the stem, the other side is the leaf. Now if you look here at these numbers, we only have 1 digit in front of the decimal. So what we would do with these numbers here, we would look for the lowest digit, and it looks as though the lowest digit is 2, and the highest digit in front of the decimal is 7. So we would do our stems from 2 to 7. And our leaves is only one digit behind the decimal. So our leaves is just the numbers that you see. And you can write them as you see them. You don't necessarily have to have them in order. But let's take a look at 2. Now we look here at 2. We add 2.4. So that would be 4 for a leaf. We add 2.5. Be 5 for a leaf. We add 2.7, and then we have another 2.5. So we could do 5 and 7. Now, 3. We look here, we have 3.1. Let's see, we had 3.6, and we had 3.2. Say 4. We have 4.4, then we have 4.8. So it'd be 4, 8. And if you notice here, I did not use any commas. You do not use commas when you're writing out the leaves. Okay, 5, we have 5.3. Let's see, 5.3, we have 5.9, and we have 5.4. So 6, we look here at 6. We have 6.4, and we also have a 6.2. And then we look at 7 here. We got 7.1 twice. We have 7.6, and we also have a 7.8. So this is the stem and leaf plot for problem number 6. Now number 7, a population consists of all subjects under study. Population is all subjects under study. Okay, number 8. When an existing group of subjects that represent the population is used for a sample, it is called a blank sample. And that would be cluster. Be considered a cluster sample. Okay, now we move on here and we go down to the next page. It says here, the ages of 40 community college students were gathered. Construct a frequency distribution for the data using 5 classes. Okay, now we do 5 classes and we want to find the width of those 5 classes. So what we would need to do is this here. We would take the range, which is the highest value minus the lowest value. So let's look here. What is the highest value? Okay, so far I see 53, but then I see 54 here. So far 54 is the highest. Let's see if we have anything higher than 54. No, we don't. So 54 is the highest. And then now we want to find the lowest value. So far 16. Okay, now I see 15. Okay, so 54 is the highest, 15 is the lowest. So it'd be 54 minus 15 divided by 5, because we want 5 classes. 54 minus 15 is actually, what's that, 39? 39 over 5. We can put that in our calculator. That'll be 7.8. And we know we will make the width 8. Okay, so now we made the width 8. Now we have to do our classes. Now if you want to do the tally marks, you can. But a lot of times I do not. But you can do the tally marks. You would just make an extra place for the tally marks. Okay, the class. The lowest amount was 15. 15 is a good number. So we'll go up. We'll go up by 8. So we know we're going down 5 classes. So that'll be 23, 31, 39, and 47. So that would be all of our lower limits. Now our upper limits, we know this would be 22, but we will go up by 8 as well, 30, 38, 46, and then 54. These are our classes. Now we have to do our frequencies. Now, just to expedite time, 15 to 22, there will be 11 values. 23 to 30 is 2, 31 through 38 is 7, 39 through 46 is 11, and 47 through 54 is 9. Now, this adds up to 40, so you should count and make sure that you have 40 values here as well. All right, so now that took care of problem number 9. This is actually problem number 9. Okay, now for problem number 10, it says the grades on a college math exam are shown below. It says construct a stem and leaf plot for the data. All right, so we would do a stem and leaf plot. We have our stem, we have our leaf. All right, so now we look here and we try and find the lowest value. You look at all these numbers, the lowest value is 50. Then we go for the highest value. The highest value is in the 90s. It looks like it's 99. So we would start off, we would go 5 to 9 for our stem and leaf plot. So under the 5, which is the 50s, we will add 0, 0, 3, 7, because there's two 50s, a 53 and a 57. The 60s, it'll be 65 and 68. The 70s, you add 70, 71 twice, 73 twice, 75, 76 twice, 77, 78, and 79 twice. I almost ran out of space there, but we have it. All right, next we have our 80s. We will add 80, 83 twice, 84, 87, 88, and 89. And remember, there's no commas in between the numbers. And then the 90s, we had 90, 92, 95 twice, and then 99. All right, now, problem number 11. A researcher numbered all of the colleges willing to release grade information and chose several of them using a random number generator. Identify the sampling method used. So since they use a random number generator and each one had a fair chance, it'd be random because they were randomly chosen, randomly picked. So now we move on to problem number 12. It says, as an experiment in a botany class, plants are placed in a greenhouse and their growth in centimeters after 25 days is recorded, with the results shown below in a stem and leaf plot. How many plants grew to 205 centimeters? Now, if you look here, the stems are 1 digit. The leaves are supposed to be 1 digit here. So this is 13, and then this is 20, all the way up to 59. None of them grow to 205. So A for number 12 would be none. B, how many plants grew to 36 centimeters? So if you look here at the stem and your leaves, you have 2 values for 36. So you'll write 2. C, how many plants had their growth measured and recorded? So an easy way to count this up, since it's not given to you in the directions, is count your leaves. Remember, your leaves represents 1 number. So if you count your leaves, that'll tell you how many numbers you actually have. So it's this 3, that'll be 8, 12, 20. It'll be 20. Then finally D, what was the largest growth recorded for any plant? It'll be 59 centimeters, because 59 is the highest value. Now 13, a blank sample is taken by numbering each member of the population, then selecting every kth member, where k is some natural number. And that will be systematic. (14) It says, in order to obtain a blank sample, every subject of the population has to have an equal chance of being selected. So that'll be a random. Now we come here to 15. It says 500 college graduates were asked how much they donate to their alma mater on an annual basis. Find the mode of their responses, summarized in a table. Now we know mode is the number or numbers that appears the most. If all values only appear once, then there is no mode. But if you could look here, even though the amounts are named here, you look at the number of people that gave that amount to tell what is the most frequent amount here, and it would be nothing. So 15 would be nothing. Okay, 16, to find the blank, arrange the data in order from smallest to largest. If the number of data values is odd, it will be one value in the middle of the ordered list. If the number of data values is even, it will be the mean of the two middle values. So that would actually be the median. Now, for 17, it says 40 new automobiles were tested for fuel efficiency by the Environmental Protection Agency in miles per gallon. The individual values and the frequency distribution are displayed below. So they took that information and they also gave us the frequencies. Now we're asked here, use the frequency distribution to approximate the mean. All right. So we know the mean is the average. And under normal circumstances, all we would do is just add all these values together and divide by how many values that we have. But the problem here is we have group frequency. So we cannot pick specific numbers. So what we would have to do is what we did back on page 378 from section 4.5 in your course pack. If you look back on page 378, it shows us what to do when we have a group frequency. And what we would need to do, I would need to draw another chart here. Now they give us the class and they give us the frequency. But in between the class and frequency, we must have what is called the midpoint. And I will go over this. So the class will be here 8 to 12. And the frequency is 1. And then we have 13 to 17, frequency 3. 18 to 22, frequency 8, 23 to 27, frequency is 14, 28 to 32, frequency is 9, and 33 to 37, frequency is 5. Now I just rewrote the information we already had. The only thing we don't have here is the midpoint. And remember, the midpoint is basically the middle value between these two values here. So you could add the upper and lower limit together and divide by 2. This midpoint would be 10. Now, there's an easy way of writing out the rest of these. What you could do is find out the width between the classes. To go from 8 to 13, that's 5. Okay? So that would mean that the width of the midpoints would be the same. So we could just keep adding 5. And we took care of the midpoint. So now, our next step would be this here. We have to take the midpoint and multiply by the frequency. So 10 times 1 is 10, 15 times 3 is 45, 20 times 8 is 160, 25 times 14 would be, what, 350? 30 times 9 is 270, and 35 times 5 is 175. Okay, now, we would take our calculator and add all of these values up. So we have, what's that, 10 plus 45 plus 160 plus 350 plus 270 plus 175. That'll give us 1,010. Now, we need to take this 1,010 and we need to count our frequencies up. We can add up all the frequencies. This would be 26, 35, this is 40. So it's 40 values total here. So we would take this 1,010, the mean would equal to the 1,010 divided by 40. So we could put that in our calculator. 1,010 divided by 40, and it'll give us 25.25. That will be your mean. 25.25 would be the mean. All right. Now, we move to problem number 18. It says, these data represent the grades on a college exam. Find the mean. So basically for problem 18, it's basically set up the same as the previous problem. We want to find the mean again. So we will have to do another little chart, or a table, I should say. Got class, midpoint, and then frequency. So the classes, we have 50 through 59, that's 1, 60 through 69, that's 3, 70 to 79, it's 14, 80 to 89, that's 18, and 90 to 99, that's 7. Now, we have to add these values up and divide by 2, just one of them, to find the midpoint. So we could do 50 plus 59. And that gave us 109. And we'll divide that by 2. So it'd be 54.5. Now if you look here, so we don't have to reinvent the wheel, we know the class width is 10. So we could just do 10 for each one. So we'll go from 54.5 all the way to 94.5. And now we take these values and multiply them by their frequency to get their value. So we'll go back here to the calculator. So we have 54.5, well, 54.5 times 1 is 54.5. 64.5 times 3 gives us 193.5. 74.5 times 14 is 1,043. 84.5 times 18 is 1,521. And then 94.5 times 7 is 661.5. Now we have to add all of these values together. So we will have 54.5 plus 193.5 plus 1,043 plus 1,521 plus 661.5. So that'll be 3,473.5. So now, that's how much it is when we add all these values together. Now what we have to do is find out how many values we actually have by adding up the frequencies. 1 and 3 is 4, plus 14 is 18. 18 and 18 is 36, plus 7 is 43. So we have the mean is equal to 3,473.5 divided by 43. So we'll put that in our calculator. 3,473.5 divided by 43. And that will give us a mean. We round that to 2 decimal places, 80.78. All right. Now, we move on to the next page. Page 19. It says find the mean, median, mode, and mid-range for the data provided. The data shows hours spent at work for a group of men. Okay, so we have our hours here. Now let's see. The easiest one to do first. Now no, we're supposed to go in this order. And when they ask you for it in this order, you need to write it down in this order. Mean, median, mode, mid-range. Okay, now, the easiest thing to find here would be the mode. If you notice here, with the mode, there is no mode because everything appears only once. So mode would just be no mode. Okay, now, the next thing that would be easy, and if you notice, if you go down here to Roberto, if you notice, these numbers are actually in order from the smallest to the largest. So we could do the median next. The median would be the next easy thing. Well, actually, the mid-range would be, but let's go on and do the median. We had 2, 4, 6, 8 values. So we need to take the middle two numbers. The middle two numbers will be these two values because it's just as many numbers above these two values as below these two values. So for the median, we'll take the 45.7 plus the 43.3 and divide it by 2. Now when we add these up, this will end up being 89 divided by 2, which would be 44.5. So the median is 44.5. Now the mid-range is easy, especially since the numbers are set up from smallest to greatest. The mid-range, you would add the smallest value plus the largest value and then divide by 2. Now when you add these two together, this would be 93.4 all over 2. And if you divide this by 2, this will give you 46.7. So the mid-range would be 46.7. Now we come to the last thing, which is the mean. Now the mean takes a little while. It's not hard, but it just takes a little while longer than the rest. So what we will have to do with the mean, we need to add all of these up. And then we would divide it by 8. So we have 64.3 plus 58.3 plus 56.9 plus 45.7 plus 43.3 plus 40.7 plus 35.1 plus 29.1. Okay, now that took care of the numerator. The denominator would be 8. And so our mean would actually be 46.675. Or 46.68. Either one would be acceptable. Okay. So now that took care of problem 19. Now we go to problem 20. It says the blank is the value that occurs most often in a data set. That would be mode. So 20 would be mode. Now 21. It says the mean, also known as the arithmetic average, is found by. So this is found by adding all values and dividing by how many values you have. So you add all the values and then you divide by how many values you have, which we basically just did in problem number 19 for A. Okay, 22. If a student's rank in a class is 500, a class of 500 students is 120, find the student's percentile rank. Okay, so they're ranked at 120. So what we need to do is find how many students are actually below them. So if they're ranked at 120 out of 500, so what we would do for this problem, we would do 500 minus 120, and we'll divide it by 500. 500 minus 120 is actually 380 out of 500. Now we could put this in our calculator. So we have 380 divided by 500. And that gives us 0.76. But they want us to write this as a percent. So 0.76 is 76%. All right. 23. The numbers below are the percentages of all drug possession arrests in a particular country that were for marijuana for the years from 2005 to 2014. Find the sample mean, standard deviation, and coefficient of variation. Now, we know that we would have to actually do this first. The first thing we should do is take the find the sample mean, or just the mean. Okay, so with this being the case, what we would do is this here. We would make a table, and we will put in these points here. So we have 42.5, we have 41.6, 40.4, 45.3, 38.1, 45.1, 38.9, 44.5, 37.9, and 45.8. Okay, these are our values. All right. Now remember, I told you all before, we could go right here to function. Matter of fact, I need to go down here first. Okay, so we'll go here to function. And what we would do, move this over a little bit, we would go to stat. And then we could go to mean. And we would type in x1. And the mean is 42.01. So we have our sample mean, which is 42.01. Now they want us to do a standard deviation. Now, we could go right here to function, go down to the next value here. We can go to function, and we can go to standard deviation, and we could type in x1 again. And our standard deviation rounded to 2 decimal places is 3.09. Now, they want us to find the coefficient of variation. Now, the coefficient of variation, or the CV, is equal to the standard deviation divided by the mean. The standard deviation in this case would be the 3.09. And the mean is 42.01. So now we put that in our calculator. So we will have 3.09 divided by 42.01. Now we would want to round this to 3 decimal places. So this would be approximately 0.074. Now, we move on to the next problem, problem 24. It says Helga scored in the 70th percentile rank on an exam. If 300 students took the exam, how many students scored lower than Helga? So, to figure out how many scored lower than her, we would take 300 and multiply it by 0.70, which would be 210. That's how many scored below her. Now, if we wanted to know how many people were above her, then we would have did by 30%. Because if she's in the 70th percentile, that means 30% is better, is higher than her. Okay, 25. It says a blank that's large relative to the mean tells us that the data values vary pretty widely from the mean. A relatively small blank means that most data values are clustered fairly close to the mean. So both of these are standard deviation. And I'll write it twice so you will know that it's both answers. It's standard deviation. Okay, 26. Which data set will be likely to have the larger standard deviation? Explain. Data set 1, weights of all dogs at a golden retriever rescue shelter. Data set 2, weights of all dogs for sale in a pet store. It'll be data set 2 because weights will vary significantly at a pet store. So again, data set 2 because weights will vary significantly at a pet store. We have to remember that when you're dealing with weights of all dogs at a golden retriever rescue shelter, they're all the same breed. So it will be assumed that they will be very close in weight. Even though some might be smaller, some might be larger, but still they would be very close in weight. But at a pet store, you can have anything from a Chihuahua to probably a Great Dane. So that is why it will vary more. Okay, now 27. If a student's rank in a class of 300 students is 66, find the student's percentile rank. So, what we would need to do here is divide, let me see, it says 66. So there's 66. So what we would need to do is take the 300 minus the 66 and divide it by 300. Because we need to see how many people are below this student. So this would be 234 divided by 300. So we will go here. So we add 234 divided by 300. So that'll be 0.78, which is 78%. Okay, now we move on to the next problem, 28. It says, assume that males have a mean height of 69.1 inches with a standard deviation of 2.9 inches, and females have a mean height of 63.7 inches with a standard deviation of 2.7 inches. Based on z-scores, would a 5 foot 4 inch male or a 4 foot 10 inch female be taller compared to the rest of their gender? Okay, now, first of all, we need to remember what the z-scores value is. Is some value minus the mean divided by the standard deviation. So we're going to take these values and convert them. Now, first of all, let's do the male, because that's what's listed first. So I just put the male. And then I would do the z-score for the male. Now the value that we're talking about for the male, they're 5 feet 4 inches tall. So that means they're 64 inches in height minus the 69.1, which is the mean, divided by the standard deviation, which is 2.9. So this would give us a negative 5.1 over 2.9. So we'll go here, negative 5.1 divided by 2.9. So that would give us an approximate value rounded to 2 decimal places of a negative 1.76. Now that is the male. Now we're going to go to the female. The female, say she's 4 feet 10 inches tall. So that would mean that she is 58 inches. So we will have her z-score is 58 minus the mean height of a female is 63.7 divided by the standard deviation, which is 2.7. So when we subtract this will be a negative 5.7 all over 2.7. So negative 5.7 divided by 2.7. And that'll give us, our z-score will be a negative 2.11. Now, we found the z-scores for both. Now we ask which is taller. And we could say that here, the male is taller because the male's z-score is closer to 0. Because remember, since both of them is negative, the number that's closest to 0 is the higher value. So since negative 1.76 is closer to 0, that means that the male is taller based upon their gender. All right. Now we move on to 29. It says if a student scored 1227 on the SAT test, which has a mean of 1,026 and a standard deviation of 210, and then scored 110 on an IQ test with a mean of 100 and a standard deviation of 15, determine which test she did better on and explain your reasoning. Okay, so basically we're doing another Z-score type problem. So this is problem 29, and we would do, let's do the SAT, and we're going to do the Z-score for the SAT. Now remember, we take the person's actual score. They scored 1227, and then the mean, which is 1,026, divided by the standard deviation, which is 210. Now the IQ test, the Z-score, the actual score was 110 minus the mean of 100 divided by the standard deviation of 15. So 1227 minus 1,026 would actually be, what's that, 201 over 210. And 110 minus 100 is 10 over 15. Now we put these in our calculators. Get these decimals. Say 201 divided by 210. That'll give 0. Let's round to 2 decimal places, 96. And then we would do 10 divided by 15, which would be 0.67 when we round to 2 decimal places. So they ask us which is better. The SAT is the better score because it is more standard deviations from the mean. Okay, now problem number 30. Problem 30. Assume that the finishing times for a group of runners in a marathon race are likely to be normally distributed. The mean finish time for male marathon runners is 291.57 minutes with a standard deviation of 39.2 minutes. The mean finish time for female marathon runners is 294.77 minutes with a standard deviation of 39.6 minutes. With a male with a time of 128.62 minutes or a female with a time of 138.95 minutes finish faster relative to their gender. So basically we're doing Z-scores again. We have male, we have female. So they're saying that the male has a time of 128.62 minus the mean time for the male, which is 291.57, all divided by the standard deviation of 39.2. Now the female Z-score, we have the female had a time of 138.95, and then the female runner was 294.77 divided by the standard deviation of 39.6. Now, we can take our calculator and put these values in here. So we have 128.62 minus 291.57 all over 39.2. So that will be a negative 4.16. Now we will go back, do another one, the 138.95 minus 294.77 all over 39.6. So this z-score would be a negative 3.93. Now the question is, which one finished faster? Now we know the lower your time is when you're racing, the better you have done. So since the woman's time of negative 3.93 is closer to 0 than the male's time of negative 4.16, the male ran faster, because whichever one has the lower number is the one that is the faster. So the male ran faster with a negative 4.16 z-score. 31. It says when data are normally distributed, approximately blank of the values are within 1 standard deviation of the mean, approximately blank are within 2 standard deviations of the mean, and approximately blank are within 3 standard deviations of the mean. Now we kind of went over this before, but it's 68%, 95%, and then 99.7%. And you can actually look down here. 1 standard deviation, which is this S, is this 34.1. Wait a minute, hold on. Yeah, it says when data are normally distributed, blank of the values are within 1 standard deviation of the mean. Now, if you look here, both of these are within 1 standard deviation of the mean. You have to take the positive and the negative. So their percentages added together is actually 68.2, but it's about 68%. Okay, and then 2 standard deviations, you will go from here to here. You add all of these up, it'll be very close to 95%. And then it said 3 standard deviations, it'll go from here to here, and we add all these percentages up, and it'll be about 99.7%. Now listen, unlike the rest of these where we round to the whole percentages, if we would have rounded to the whole percentage here, that would have gave us 100%, which would have been too far off. So that's why we went to 1 decimal place. Okay, 32. Assume a data set is normally distributed with mean 126 and standard deviation 20. If the data set contains 350 data values, approximately how many of the data values will fall within the range 86 to 166? Okay, now, first of all, they tell us the mean is 120. Now, I'm not going to draw the whole chart. I'm just going to do the bottom line here. I'm just going to do the values. Oh, it's supposed to be S. X minus X. Okay. So this is what we have here. Now, they ask us, they tell us that the mean is 126. So they're telling us this value is 126. Now, they tell us that the standard deviation is 20. So we'll keep adding 20 going up. This would be 146, 166, 186. And then we would take 20 going down. This would be 106. This would be 86. This would be 66. Now they ask us, it says that the data set contains 350 data values. Possibly how many of the data values will fall within the range 86 to 166. So it's from the x minus 2, the x bar minus 2, all the way to the x bar plus 2. So it's basically from here to here. Yeah, so it's both basically those two. Okay, so if you add all of these together, you will have 13.6 plus 34.1 plus 34.1 plus 13.6. So that'll be 95.4%. So we're dealing with 0.954. And we're going to multiply by the 350 data values. So we would put that in our calculator. So we have 350 times 0.954. And that would give us 333.9. And they tell us to approximate this, so it'd be 334. That's how much it would be, 334 data values that fall in that gap there. Okay, 33. It says, assume a data set is normally distributed with mean 13 and standard deviation 3.5. If the data set contains 50 data values, approximately how many of the data values will fall within the range 9.5 to 16.5? Okay, so I'm basically going to set this up similar to what I did with the previous problem. So it'll be x bar minus 3s, x bar minus 2s, x bar minus s, and we know s is the standard deviation, x bar plus s, x bar plus 2s, and then x bar plus 3s. All right, so we have this. We're told that the mean is 13, and then the standard deviation is 3.5. So going onward, we would keep adding 3.5. This would be 16.5. This would be 20. This would be 23.5. Then subtracting, this would be 9.5. This would be 6.0. And this would be 2.5. Those are our data values. Now they ask us to go from 9.5 to 16.5. Now if you notice, that's x bar minus s, or the mean minus the standard deviation, all the way to the mean plus the standard deviation. So they want us to know how many values we have, so we would take 50 and multiply it by 34.1, and 34.1 is 68.2, or 0.682. So now we will multiply this out. So we have 50 times 0.682. So that'll be 34.1. So this would be approximately 34. That's how many data values it would be, approximately 34. Okay, problem 34. It says if a data value has a z-score of blank, then half of the data are below that value and half are above. Now remember, a z-score of 0 is the mean, which is here, which will give you half below, half above. So your z-score would be 0. Okay, 35. It says a z-score tells you how many blank a data value is from the mean. Data values that are below the mean will have blank z-scores. So first of all, the first answer is standard deviations, because the z-score tells you how many standard deviations is above the mean. And then if you have data values that are below the mean, they will have negative z-scores. So it's standard deviations and then also negative. And we are done with the last portion of your final exam review. So again, have a nice weekend. Please make sure you complete all of the work that's due, the homework, the projects, everything that's due this coming weekend. And if you have any questions, please feel free to email me. Have a wonderful day.